Welcome to Science Exploded. Now, today's show is all about the Global Positioning System, or GPS. Now, the concept of GPS was first introduced in the late 1960s. The technique of using a system of orbital satellites was first pioneered by the US Navy, who in 1965 launched the first ever GPS system. The system consisted of 5 satellites orbiting the Earth at around 12,000 nautical miles high. During the Cold War, US Polaris submarines, the ones that carried nuclear missiles, needed to spend months at a time underwater to avoid detection from the Soviets. At the time, submarines used a gyroscope-based inertial navigation system. However, this was simply too inaccurate over such a length of time. Now, the transit system would circle the Earth continuously in polar orbits, and by analysing the radio signals transmitted by the satellites, in essence measuring the Doppler shift of the signals, a submarine could accurately determine its location in 10 or 15 minutes. However, the US military was looking for something a bit more accurate and more foolproof. This new wave of technology brought about the idea, which is commonly referred to today as trilateration. The global positioning system relies entirely on the modern clock. Each orbiting satellite continuously broadcasts a radio signal which stores information of its position in space, and the time, which, with the help of an atomic clock, is accurate to a billionth of a second. A GPS receiver on the ground intercepts this signal and works out the time difference between the satellite sending it and it being received. Then, as the speed of the wave is known, the receiver uses the basic speed equals distance over time equation to calculate the distance of the receiver from the satellite. It then carries out this procedure with up to 3 other satellites, and if the receiver uses a normal quartz clock, sometimes a 4th satellite is also included. This provides unparalleled levels of accuracy, or does it? As GPS was primarily only for military use, the US government imposed some new rules when the satellites were available to civilians. Many GPS receivers now have an intentional time delay, reducing their accuracy by, in some cases, up to a mile. The reason for this was to prevent enemy hands using civilian GPS devices in ballistic missiles. For the system to work, the GPS receiver has to know exactly where the satellites are, and the satellites have to be able to keep reliable and extraordinarily accurate time. Accuracy is ensured by having each satellite carry no less than 4 atomic clocks, the most accurate timing devices ever invented by man. All the satellites orbit the Earth continuously at around an altitude of 11,000 nautical miles, giving them predictable trajectories. The Department of Defense monitors these satellites as they pass overhead twice a day and measures their speed, position, and altitude precisely. The information is sent back to the satellites, which broadcast it along with their timing signal. Now, a lot of that will have no relevance as we've just spoken to it. However, if you'll direct your attention towards the screen behind me, we're now going to show you using a simple model how the system works. Several satellites positioned in strategic places around the Earth broadcast signals which contain their position in space, their altitude, and the time at which a signal was sent. A receiver on the ground then detects these signals and calculates how far away each satellite is from the receiver, giving you your exact position on the Earth. Many military-grade devices are accurate to within a few meters. Well then, that concludes this episode of Science Exploded and the series, but we'll be back in the new year exploding more science right in front of you.